Good morning, physics. Today on Physics with Dan, we will be discussing making magnets, which is lesson 2 of magnetism within our unit, exploring gauge 2. So, with our making magnets, I'm sure you've all have done this before, where you've taken a magnet such as this, and you sort of put it near some paper clips, and you found it can pick up the paper clips. And the reason why is because this is magnetic and these are ferromagnetic, so they're able to sort of pick up some magnetism. So what happens is the magnetic field of this magnet, which is sort of going all over, doing its thing, it ends up getting spread through here, so you end up with your new true north way down here, and you have some big long chains that sort of go back in between and sort of making it a giant loop, as seen in one of the diagrams in today's reading. And the reason why this happens is magnetism is basically, if we look at our atom, so we have an atom right here. All magnets basically come down to is the idea of you have your electrons moving in the same direction. So if we have a picture of our atom, this is the nucleus, and then this is the electron. So in this bar magnet, what's basically happening is all of the electrons in the atoms within this are all rotating around their nucleus in the same manner. So they're all going in one direction, much like the name of that boy band. And what happens is that one direction is such a big influence, it ends up influencing the paper clips, so then they start spinning their electrons in the same direction, so then everything ends up going in one direction. At a certain point, however, if you take these paper clips off, much like the band itself, the direction that they all move in starts to sort of wear away, and they split up and they start to lose their magnetic properties. Now, one of the key things we can do is copper, like copper wire, isn't really able to hold its magnetic charge for a long time. However, it is very good at moving electrons through it. So if we, say, get a coil of copper wire that's insulated, so it only has one direction that it can go, and if we were to, say, hook this up to, say, a battery, we would be able to find that this would create a magnetic field very similar to our permanent bar magnet. So we'd have, although it would be kind of inside, it gets kind of cool. But to sort of demonstrate how things like a copper wire and a current moving through it can create this magnetic field, I have a nice little video of a jumping wire, which is honestly one of my favorites. So this is from YouTube. So as you can see, they have a 12-volt battery, and then they have a knife switch, which is basically a switch that can go, it can flip the direction of the circuit, and then they have this strong magnet right here, so as they hook up the 9-volt battery and they flip the switch, current goes through the wire, and then it starts interacting with magnetic field and it's able to jump. Now, as they flip it the other way, they end up sort of sending the current the opposite direction, which then makes it an attractive force and causes it to pull down, which is a really sort of neat moment. And these electromagnets that we deal with, we make them in most things, but one of the key things is that it has to be insulated in between, because otherwise, instead of having your electrons do the loop where they go all the way around, if it's not insulated, they just go bam and then bam, and they wouldn't be going in, they'd be going in one direction, but it's not sort of the direction you want. The more turns you end up having, the stronger your magnetic field can end up being, which is cool. So, to go over a little bit of the reading and questions you have to answer, let me pull those up. So over here we have a slightly better diagram of the magnetic field than what I've made. Over here showing sort of how the magnet and the paper clips sort of interact to combine and create one single larger magnetic field, although it will be much weaker. Just like how at certain points you can't add any more paper clips to it because the magnetic field has gotten so weak it's not able to apply the force necessary. And if you want to, if you manage to find some magnet wire, which most people don't have lying about, but if you do, I highly encourage you to mess around with it and make your own electromagnet. I will give you bonus points if you manage to do that. So an electromagnet uses current in a wire to generate a magnetic field, as I was saying earlier, by having all of those electrons moving in the same general direction, having the same drift velocity, and that will get them to create a nice strong magnetic field depending on how many times you get them to go in the same direction. And so basically, same with both types of magnets. You have in electromagnets, it's caused by the current, which is the moving electrons, and with the more permanent magnets, like an iron magnet, you have all of the electrons moving in the same direction, rotating about their atoms, because they're always moving. They're just all rotating in the same direction to create that magnetic field. So that is it for today. I hope you have found this useful. There is one more video of showing you a electromagnet in action. That's part of the exit ticket. And with that, they made a little electromagnetic cannon, which is pretty cool and kind of a fun thing to play with if you have both magnets and wire and batteries. So I hope you all have a nice day. Feel free to message me in the Discord or via Jupiter to set up a time to meet if there's anything that confuses you. Have a good day. Bye.